In this demo, we are going to show a real example of how an organization typically engages with the Selector platform. It highlights capabilities of the platform, including natural language interactions, automatic correlation leveraging metadata about the network, and remediation using collaboration tools. The demo begins with a user getting a smart alert in Slack, asking some clarifying questions about the event, and then pivoting to the portal to do more triage, and eventually taking remediation action via Slack. A popular endpoint for the Selector Smart Alert is Slack. As you can see in the Slack alert, we have good context about the likely cause of the event already, the devices affected, and the downstream effects. At first glance, it appears that an interface flap is causing downstream issues with BGP. After getting the alert, the operator wants to gain some more context about the current status. The first question would be to understand the device state, so the operator asks if the device is still reachable. As you can see from the response, the device is still reachable. But that doesn't mean there might not be a service degradation. So next, the operator wants to understand the potential impact. Router 1 and Router 2 appear to be in a degraded state, with two KPIs in red for BGP flaps and interface opera status. With this information, the operator wants to do more research using the Selector portal. They click on the link in the alert notification to open a dashboard that's automatically tailored to the devices and events in this notification. The first widget we're going to look at is the one for BGP sessions. This specific KPI identifies if a BGP session is flapping. This widget is automatically filtered for the devices in the Smart Alert. As you can see in the Sunburst widget, the peer interface name and peer host tags indicate the failing session is related to a common interface between a pair of routers. By clicking on one of the interfaces on the outer ring, we will see more detail about the BGP flapping. The timeline heat map gives a visual indication of the health, and the flap rate tells us the volume of the flaps for the time period. Scrolling down, we can see a line plot of all the eBGP peers for that device, and additional relevant information such as the admin status of the peer interface, configuration events, and interface uptime. At this point, we have a clear sense now that we have a flapping interface that is in turn causing BGP to flap, and that it appears to be isolated to just this pair of interfaces. So now the operator goes back to the main alert page to learn more. We can see on another Sunburst widget that the interfaces are related to a common circuit and carrier. This will be useful later when we open a ticket with them. Looking further down the page, we see various raw logs and log events. As you can see from the log events, there is a repeated interface down event on both routers, along with BFD, BGP, and LLDP events. And because we have an integration with their AAA server, we also know that there are no recent configuration changes that could be causing the flapping. So it's not caused by a human. We also have additional KPIs for the device that Selector has built. These are helpful to understand the full context of the health of the device. We see red for BGP flapping and interface opera status, with the other being green. Note the latency line plots. During the flapping events, the devices have always been reachable, but the latency for router 1 did go past the auto baseline threshold. For every device in the network, Selector will automatically create a dynamic threshold. This can be seen by looking at router 2, which has a much lower dynamic threshold due to its closer proximity to the source of the pings. In this case, since the latency deviation on router 1 is not consistent, it has not yet flagged the KPI to red yet, but it is something that should be considered when making a remediation decision. The operator now has enough understanding of the network event to make a decision on what to do next. In this case, they are going to disable the interface via Slack since there's redundant interfaces, and then open a ticket with the carrier. But before we show that, I will explain a bit more about the correlation. On the top left is a widget called Correlation Graph. It helps us understand how the various events are connected and is used in the Smart Alert. First, I will expand the widget. On the top, we have a summary of the events and the labels. Scrolling down, on the left side, we see more detail on the various labels or tags that are part of the correlation set. By increasing the correlation level, we can see all the events that share common tags along with the details of the tags. Selective machine learning continually examines log and metric events and their association levels using temporal and contextual correlation to automatically create this graph, which produces the smart alert that you saw in Slack. For example, when I hover over the BGP event, I can see the event name and all the associated labels such as local and remote AS. This additional context is the key for understanding how events are related in the network. In this case, the interface and BGP events directly relate to the circuit down event, which raises the criticality of this event for the operator. The final step is to go back to Slack and ask it to disable the interface. This same workflow can also be done directly from the portal if desired. So the operator goes back to Slack and instructs it to disable the interface on router 1.site1 so that the flapping doesn't continue and potentially degrade the site. As you can see, Selector responds with a visual indication of the interface being down.